Welcome to the channel. Don't forget to like and subscribe.
Bismillahirrahmanirrahim. In this video, we are going to solve some important numericals of chemistry for class 9. We have tried to cover all the important topics that are important for the examination point of view. The first topic is molecular mass, formula mass, and molar mass. The molecular mass is the sum of all the atoms present in the molecule. Similarly, the formula mass is the sum of all the atoms present in the formula unit. Both carry the same unit. The only difference between the molecular mass and the molar mass is of unit. The molar mass carry the unit gram. Now coming to the numericals. The first example is to calculate the molecular mass or formula mass of CO. CO is carbon monoxide. Since carbon has atomic number mass is 12 and oxygen atomic mass is 16, and by adding both we get the molecular mass of carbon monoxide, that is 28 AMU. Now, if the question is to calculate the molar mass of a carbon monoxide, the procedure will be the same, as you have to add the atomic masses of the respective element, carbon 12, oxygen 16. By adding them, we get 28. But we change the unit, that is gram. So, the molar mass of carbon monoxide is 28 grams. Now, the second topic is mole. When the atomic mass or molecular mass is expressed in gram, it is referred as mole. And to calculate the number of mole, you need to know the formula. That is, the number of mole is equals to gram mass of the substance divided by atomic mass or formula mass. Now, let's see how to calculate the number of mole with the help of the formula. So, for example, calculate the number of moles in 7.4 grams of calcium hydroxide. You will be provided with the atomic masses of the elements. For instance, calcium is 40, oxygen is 16, and hydrogen is 1. You have to make a data first. In data, you will write what you are required and what is given. You have to find out the number of mole, and the given is the given mass of the substance, which is 7.4 grams. Now, writing the formula, number of moles is equals to gram mass of the substance divided by atomic mass or formula mass. Now, coming to the solution. Since to find out mole, we must know the atomic mass or formula mass of the given substance. So first we have to find out the formula mass of calcium hydroxide. That is, by adding the atomic masses of the elements, we got 74 AMU. Since it was a formula mass, so we write the unit AMU. Now placing the values in the equation, number of moles is equals to 7.4 divided by 74. 7.4 is the given grams and 74 is the formula mass of the calcium hydroxide. So by dividing that, we get our answer, that is 0.1 mole. You can use the mole formula to calculate the mass of a substance if the mole is given. Let's see how it is calculated. Now the question is, what is the mass of 3 moles of each carbon dioxide and water? First, you will calculate the mass of carbon dioxide. You have to make a data first. Number of moles is equals to 3 moles, and we have to find out the mass of substance. Since we will be needing the formula mass of carbon dioxide, here we have calculated, which is 44 AMU. Now coming to the solution, the number of mole is equals to given mass of a substance divided by atomic mass or formula mass. Since we know the number of mole, it is 3, and the atomic mass, which is 44, placing the value in the respective places, it becomes 3 is equals to mass of a substance divided by 44. Since 44 is dividing here, and when it goes to the other side of the equation, it becomes 3 into 44 is equals to mass of a substance. So by multiplying 33 with 44, we get our answer, which is 132 grams. So 3 moles of carbon dioxide contain 132 grams. The same method will be done to find the mass of water. First, we have to find the formula mass of water, that is 18 AMU. Now, placing the value in the formula, number of moles is equals to gram of the substance divided by atomic mass of the formula mass, which becomes 3 is equals to mass of a substance divided by 18. So when 18 goes to the other side of the equation, it multiplies by 3. So 3 into 18 is equals to mass of a substance. And by multiplying 3 into 18, we get our answer, which is 54 grams. So 3 moles of water contains 54 grams. Moving to the third topic, Avogadro's number. This number is proposed by Avagadro, which is 6.02 into 10 to the power 23. This means 1 mole of a compound or an element contains 6.02 into 10 to the power 23 particles. You can use the Avogadro number to calculate the number of molecules in a compound or element. So here's example. Calculate number of molecules in 1 gram of oxygen. Now again, you have to make a data first. You have to find out number of molecule. The given mass of a substance is 1 gram. Formula mass of oxygen is 16 into 2 becomes 32 AMU and the Avogadro number. Now coming to the solution, as we know that the number of molecules is equals to given mass of a substance divided by formula mass into the Avogadro number. Now placing the values in the equation, so number of molecules becomes 1 upon 32 into 6.02 exponent 23, and by dividing 1 by 32 we get 0.0312, and when we multiply it to Avogadro's number 6.02 exponent 23, we get the answer, that is 1 gram of oxygen contains 0.187 exponent 23 molecules. Let's look into another example. We can calculate the number of atoms in 4 grams of carbon as well by using Avogadro's number. Making data, coming to the solution. Now placing the value in the equation, number of atom is equals to given mass of a substance divided by atomic mass into Avogadro's number. So the equation becomes number of atom is equals to 4 divided by 12 into 6.02 exponent 23. When 4 is divided by 12, it becomes 0.33, and when it's multiplied into 6.02 exponent 23, we get the answer, which is the number of atoms in 4 gram of carbon atom is 2.004 exponent 23 atoms. We can use the Avogadro number to calculate the mass of a substance as well. Here's example. Calculate the mass of 1 molecule of water. Making a data first, number of molecules is equals to 1 molecule. You have to find the mass of a substance. Since we require the formula mass, so the formula mass of the water is equals to 18 AMU and the Avogadro number. Coming to the solution, as we know that the number of molecule is equals to given mass of a substance divided by formula mass into Avogadro number. So by placing the value in the equation, we get 1 is equals to mass of a substance divided by 32 into 6.02 exponent 23. And now by doing some simple mathematical calculation, we get the answer, that is the mass of the water is equals to 5.315 into 10 to the power minus 23 grams. Now the fourth topic is the number of electrons, protons and neutrons. So in order to find out the number of electron, proton and neutron in an atom, you must understand what is atomic number and mass number. Atomic number is the number of electron or proton present in an atom, and it is represented by the letter Z. Whereas the mass number is the sum of proton and neutron present in the nucleus of an atom, and it is represented by the letter A. Now let's see how we calculate the number of protons, electrons and neutrons with the help of the example. We are given with 3 elements, nitrogen, sodium and aluminium. The atomic number and mass number of the elements will be provided. As the atomic number of nitrogen is 7, so the number of proton and number of electron of nitrogen will be 7. And for the number of neutron, we have to subtract the atomic number from mass number. So by subtracting 7 from 14, we get the number of neutron, that is 7. And the same procedure will be done to find the number of electron, proton and neutron in aluminium and sodium as well. Now let's look into another example. How many electron, proton and neutron are present in the following ions? Here we are giving some ions and we have to find out the number of electron, proton and neutron in them. When an atom gains electron, it becomes an anion, and when it loses electron, it becomes a cation. So here in this question, we are given 2 anions and a cation. So here for the oxygen anion, the number of proton is 8 and number of electron is 10, since it has gained 2 electrons. And the procedure for the number of neutron will be the same. You have to subtract the atomic number from the mass number. So we get 8. The number of neutron of an oxygen anion is 8. The same procedure will be done for the chlorine anion. Now the third example is a cation. So for the cation, the number of proton will be same, but the number of electron, we have to subtract 2 electrons since it has lost its 2 electron. So the number of electron in the magnesium cation will be 10. And similarly, for the number of neutron, we have to follow the same procedure. We have to subtract the atomic number from the mass number. Now, our fifth topic is molarity and molality. Molarity is basically the number of moles in a liter of a solution, whereas molality is the number of mole in a kilogram of a solution. Let's learn how to calculate the molarity with the help of example. Calculate the molarity of a solution that contains 2 moles of NaCl, sodium chloride, dissolved in 0.5 liter of a solution. Making data first, we have to find out molarity. The number of mole which is given is 2 moles and the volume of solution is 0.5 liters. Now coming to solution, since molarity is equals to number of moles divided by volume of solution in liter. So by placing the value in the respective places, we get molarity is equals to 2 upon 0.5. So by dividing this, we get the answer. So the molarity of 2 moles of NaCl dissolved in 0.5 liter of solution is 4 molar. Let's see another example. Calculate the molarity of a solution that containing 20 gram of NaOH, sodium hydroxide, in 250 centimeter cube of solution. Here, the volume is given in centimeter cube, not in liters. There will be a slight change in the formula of molarity since the volume is given in centimeter cube. Again, making the data first, the molarity, the mass of solid which is 20 grams, volume of solution 250 centimeter cube, and formula mass of sodium hydroxide which is 40 AMU. Coming to solution, when the volume of a solution is given in centimeter cube, the formula to find out molarity will be molarity is equals to mass of solute divided by formula mass of solute into 1000 divided by volume of solution in centimeter cube. So by placing the values in their respective position, we got molarity is equals to 20 divided by 40 into 1000 divided by 250. And now by calculating, we get the answer. So the molarity of 20 gram of sodium hydroxide in 250 centimeter cube of a solution is 2 molar. Now coming to molality, calculate the molality of an aqueous solution of sodium hydroxide that contain 5.3 grams of sodium bicarbonate dissolved in 500 grams of solution. Making data, you have to find the molality. The mass of solute is 5.3 grams, volume of solution is 500 grams, and the formula mass of sodium bicarbonate is 84. Coming to solution, the formula to find out molality is molality is equals to mass of solute divided by formula mass of solute into 1000 upon volume of solution in grams. So, placing the values, molality becomes 5.3 divided by 84 into 1000 upon 500. And by doing the mathematical calculation, we get the answer. The molality of an aqueous solution of sodium hydroxide that contains 5.3 grams of sodium bicarbonate dissolved in 500 gram solution is 0.12 molar. Since it's a molality, so its unit is small m. The sixth topic is mole fraction. The mole fraction is basically a ratio between the moles of a component and the total number of moles making up the solution. A solution has been prepared by dissolving 2 moles of ethyl alcohol in 3 moles of water. Now calculate the mole fraction of ethyl alcohol and water in this solution. The mole of first component, that is ethyl alcohol, is represented by N1, which is 2, and the mole of second component, water, is represented by N2. Whereas the mole fraction of first component ethyl alcohol is represented by X1 and the mole fraction of water is represented by X2. Here is the solution. Since the mole fraction is the ratio between the moles of component divided by total number of moles making up the solution. First, we will calculate the mole fraction of ethyl alcohol. So X1 is equals to the number of moles of ethyl alcohol divided by the total number of moles, N1 plus N2. So the equation becomes 2 upon 2 plus 3, and by calculating we get the mole fraction of ethyl alcohol is 0.4. Now the mole fraction of second component, which is water, so the equation becomes x2 is equals to n2 divided by n1 plus n2. So by doing the calculation, we get the answer. The mole fraction of second component is 0.6. You can also verify your answer by adding all the mole fraction of the components, and the answer must be 1. Now the next topic is Faraday's first law of electrolysis. Calculate the amount of silver deposited at cathode when 10 amperes of electric current is passed for 1 hour through the solution of silver nitrate. The electrochemical equivalent of silver will be given. Now the data. We have to find out the amount of substance represented by W. The current, which is represented by A, is in 10 ampere. Electrochemical equivalent Z is given. The time, which is given in hours, must be converted to seconds. So 1 hour is equals to 3600 seconds. Here is the solution. The Faraday's first law of electrolysis is represented mathematically as W is equals to Z into A into T. Now placing the values in the respective places, we get the answer that the amount of silver deposited at cathode when 10 ampere of electric current is passed for 1 hour through AgNO3 is 40.248 grams. Let's look into another example. A current of 5 ampere will pass through a solution of copper sulfate for half an hour. Find the mass of copper metal deposited at cathode. The electrochemical equivalent of copper is given. Here's the data first. Amount of substance, current, electrochemical equivalent, and time. Since time is given half an hour, so when converted into seconds, it becomes 1800 seconds. As the mathematical expression of Faraday's first law of electrolysis is W is equal to Z into A into T. So by placing the values, we get the answer, which is W is equal to 0.164 gram. Now the last topic is pH and pOH. Calculate the pH and pOH of a 0.1 molar nitric acid solution. We need to find the pH and pOH where the molarity is 0.1 molar. Now by using the formula pH is equal to minus log of H positive ion, we have to convert the molarity into scientific notation. So 0.1 becomes 1 into x 10 raised to power minus 1 molar. Now the equation becomes pH is equal to minus log into 1 raised to power minus 1. By doing the log calculation, we get the answer pH is equals to 1. And for pOH, we know that the sum of pH and pOH is 14. So the pOH becomes 30. Now calculate the pH and pOH of a 10 raised to power minus 10 molar solution of NaOH. Now the data, moving to solution. pOH is equal to minus log of OH negative ion. Now placing the values, we gain pOH is equal to 1. And for pH, we know that pH plus pOH is equal to 14. So by subtracting 10 from 14, we get pH, that is 4. Thank you for watching the video. And if you like the video, please don't forget to like and subscribe our YouTube channel.